Yeah, everybody, you know Dianne Alps, and if you know, I sent an attachment with her picture, her gorgeous picture, and a reminder of everything Diane's involved in. So she's a voice of authority here on marine mammals. And I want to tell you that this particular enrichment Zoom is going to help with the new exhibits because we talk about migration there. This is about migration of marine mammals, and in the exhibits we talk about migrations as a whole as well. So I'd like to welcome Dianne, and it's yours, Dianne.
Thank you. And thank you, Anne, for inviting me again. I'm so happy to see you guys. And I hope all is going well. And we were just talking about how the world is just ramping up. And, hopefully we'll be able to get back to some semblance of normal and maybe even see you guys out on a whale watch boat one day soon. But I'm really happy to be here. I do love to chat with you guys. I'm not just here to deliver content. I want to know what you're curious about. I want to make this a conversation. So I encourage you to turn your camera on so I can see your faces, because I'm actually looking at your faces, not my slides. I know my slides, I don't need to look at them. I'd rather talk with you. So if you're comfortable, go ahead and turn that camera on. And I have my chat box open. If you have a question, you can raise your hand or pop a question in the chat. Maybe I can get Denise or Anne to let me know if something comes up. And feel free to ask away. And let's talk about whales and migration, or our ocean wanderers. So we're actually specifically looking at marine mammals, but we're going to take a look at a lot of ocean wanderers. And we're really going to refer to them as marine mammal movements and migrations. I know that the big question right now is about humpbacks and gray whales. So we're going to talk primarily about those two, but we're going to look at how we know what we know. And so let's dive in, if you will, to use every ocean pun we can, and we'll get started. So of course, you just can't really talk about marine mammal movements without looking at a gorgeous image of our world's oceans, just to get started and set the tone. So what I want to know from you guys is, what is migration? So go ahead and turn those mics on and give me some definitions. What is migration? If you're going to use that term in your tours, got to know what it is.
Moving to the next place to be that's going to help the animal survive.
Moving for survival. Okay. And what are the reasons for that? Beyond survival, what would be the reasons for that? Or what are the reasons for moving? Why not stay in one place for survival?
Food and breeding.
Food and breeding. Those are the primary reasons. It's pretty much looking at, typically in the case of a true migration, it's looking at a seasonal movement of animals moving from one reason to another. And the reason why definitely is primarily to do with feeding and breeding. So we're going to talk a little bit about that. This beautiful Arctic tern picture here. Now, of course, I'm jumping out of marine mammals, but you can't really talk about migrations at all without recognizing, tipping a hat to, and just having a wow moment about the Arctic tern. So photo courtesy of Bernardo, and he pulled this information for me. You can see the image in the top right is tagging data from an Arctic tern, and you can see it going all from pole to pole. If you look at the green or the yellow traces here, you can see, and it's not even direct line pole to pole. There's a lot of movements in between, and even a lot of almost not full circumnavigation, but a lot of moving laterally as well. So these are animals that move very, very far. And you can see down at the bottom, the annual round trip of the Arctic tern is approximately 71,000 kilometers. 71,000 kilometers. And check this out, just for some fun facts. The lifetime may exceed 2.4 million kilometers, or the equivalent of 3 return journeys to the moon and back. Wow. To the moon, Alice, right? So anyway, So it's pretty amazing if you think about that. And, you know, for such a small animal, they've got to constantly be taking in fuel to be able to, you know, give the fuel for that journey. So anyway, just a
And
wow. Yeah.
what's the significance of the yellow, the green, and the red? Are those different species or?
Different individuals.
Oh, okay.
Different individuals. So we talked about the two primary needs an animal has for survival and what drives this migration, feeding and breeding. And within marine mammals, with a lot of animals, but we're going to now focus on marine mammals, there's two differences now looking one step closer at that. There's a resident or non-migratory marine mammals. They feed and breed in a similar area or may disperse to follow food, but they don't have a defined migratory path. And then you also have the highly migratory animals, such as the two primary species that we'll be talking about today, gray whales and humpback whales that are highly migratory. When you look closely at the migratory needs, again, feeding and breeding, we have within these animals, especially when we start talking about humpbacks, there's a lot, several different populations. And what defines a population is their breeding ground, not their feeding ground, because many animals may convene to a similar feeding ground to share that resource, that all that prey, but then they may distribute out and go to their own breeding grounds. We'll see some maps that make a lot of sense of that, but you can see here on the left, you have one shared feeding ground and then two populations looking at the breeding grounds. You guys see where I'm talking about here? So that would be two populations of animals. Another look at that could be sharing a breeding ground and going to different feeding grounds. That's a little bit less common, but then that would be one population. Again, the population is always referring to the breeding population. Where they meet to mate and calve is how we define the population. And that's really going to be important when we look at the humpbacks. And again, at any point, if you guys have any questions, just let me know. So how do we know all of this? You know, these are animals that are traveling far offshore. We are given information such as population estimates and when they're coming by, and, you know, we're able to get some information, but how do we track individuals and distances? Well, one way that we can do this is through the use of photo identification. The science itself is called mark recapture, and it can be done with any species. You can, you know, in a lot of cases, you might, what was the original one we studied? Was snails. You remove them from their habitat and mark them, and actually maybe put a piece of paint or a number on them somehow, put them back into their habitat. And then when you do another collection, you see if you have any that were marked before, and that can help. Using calculations, you can determine how many may be in that overall population of snails if you continue to recapture animals that were numbered on a previous capture, or if they're none are marked every time you collect from the pool. So it's a way to assess populations. With whales, it's not so easy. We're not going to put numbers on them so much, but we found a very non-invasive way to do that is that a lot of these animals have very unique markings. And so we can take a photograph and keep track in databases and catalogs of the individuals every time we see them. So number one, that gives us some very detailed information about an individual. We also then can look, as my example of the snails, is you can look at the entire population. In this case, these pictures are humpback flukes. We can know more about a population if we never see that individual again. Every time we go out into that region and we take pictures of all of their flukes, but we're not seeing that individual, we may know that it's a larger population. Where if we see that individual on a regular basis, we will, you know, and we're sampling as many animals as possible, we may know that it's a smaller population. Does that make sense? You guys with me so far? A little thumbs up or so, some nods, good. So this also, but in this case specifically, what we're looking at is how this will give us some fine scale detail about an individual. So if I you know, if we see this same individual, boy, let's use the top left one here, who's had some definite encounters with killer whales. You can see that fluke, this one we would definitely call lucky with a capital L, because it's probably had a pretty aggressive attack with killer whales. It's missing the tip of its flukes. It's got lots of tooth marks we call rake marks. It would be probably a very easy one to recognize. And so throughout this species range, every time a picture of this animal, this individual is taken, we can track its movements over time. We can see if it's feeding in Alaska and breeding in Hawaii, or if it's feeding off of California and breeding in Mexico, if we have researchers there that are taking pictures and sharing that information. We also can get a great detail into more of their life history, if it's a male or a female, because if we see a presence of a calf, how often it may be calving. There's an enormous amount of information that we can gather just from this non-invasive research technique. With gray whales, they don't always fluke as often. We typically see and utilize their dorsal ridge area, right at the peak of the dorsal ridge. And you can see here 2 different gray whales. And so this is the technique that's used for capturing a photo identification of a gray whale. Now, gray whales are really hard. There's over 20, well, up to at their peak just a few years ago, about 27,000 gray whales in our eastern North Pacific population, those that travel very close to our coastline. Of course, we've had our unfortunate die-off event recently, and the newest numbers that have just been released are about 21,000. So we do think there's been a significant decline in the population of our gray whales. But the catalog is just, that would be just too many animals. So really, there is no complete catalog. There's some individuals that are very unique that are seen that we try to track, but there is not a complete catalog of gray whales. But we do still get some good information from animals that feed in certain little resident areas. But I think it's really important to note, we don't have a lot of details on individual gray whales up until recently, okay? So let's take a look at now some newer technology. And actually this, I say newer, and you can see the date on the top here is 1976. I'm looking here at a pinniped time depth recorder, in that the studies on pinnipeds were some of the first where we used devices to be able to study their depth movements. And you can see how large this one was, and it's not even one of the largest that was started with, but you can see it was a pretty big package that was strapped onto an animal. They're much smaller now. This is a small computer that, and you can imagine in looking at the dates of this as well. So the technology has gotten so much smaller, and you can imagine how much more we're getting from it, right? So this computer, literally a computer, is going to be tracking things almost, you know, pretty much anything that's your cell phone. You know, your cell phones can pick up all of your movements, and including your pitch, roll, and yaw, your location. And so, yes, that's all right here in your phone being tracked all the time, but so are these animals, and a lot of that technology was applied to tags. Whales, one of the common tags that's put on whales are these suction cup tags, and you can see that being held here. This one was from about 15 years ago, and they've gotten even more compact in many ways. This is my hand, so you can see about the size of this one in the bottom right-hand corner. This D tag or data tag has cameras, and now they have rear and forward facing cameras. It also collects audio, so it can hear any sounds the animal might be making, but also sounds in the ambient sounds. The amazing amount of data that can be collected from tags that are put on whales, I think it's just ever growing. They're taking water samples, they're taking temperature readings. A lot of these will, when they come to the surface, send a signal to the GPS satellites. So in real time, researchers can track the location of their tag, the location of their animals. Suction cup tags are meant to stay on for a very short term, typically 6 to 8 hours, sometimes up to 36 hours or so. And they have to be recovered by scientists. So all of the valuable data is gathered and recorded, and then these pop off. They have a long UHF antenna, and the researchers will go out and track it down with a UHF receiver to be able to pick up that tag and get that data and download it. But they are sending live signals of GPS location. There are also GPS. Yeah, was there a question? No. There are also GPS satellite tags, and these are a little bit different. And I don't have a picture of one. These days they're about cigar shaped, and they're actually embedded into a whale. The technology has gotten much better in that they are smaller. Cigar shaped is much smaller than they originally were. And they're embedded into the whale. And these tags also have like an antibiotic timed release. So over the length of the time the tag is embedded, it's emitting this antibiotics to help heal the area, because it can, it's embedded into an animal, so it can create wounds, infections, and nobody that studies animals wants to hurt them, especially long term. Those tags are pretty amazing. They don't get recovered, but they send, because they're embedded, they will stay for a longer duration. They typically will stay up to 100 days, and there are some records where they can stay up to and a bit over a year. And that gives, you can imagine, you're not getting that fine scale, every movement, how many times you've dove and how fast you're moving, but it does give all of your location data for that course of the time that tag is active. So for up to a year or over a year. And that's where we're starting to get some really detailed information about these migratory paths. Everybody good with our technology? I'll show you a little bit about where some of this technology has brought us and some of this information. This slide is courtesy of Dianne Costa up at UC Santa Cruz, who studies elephant seals, but also started a project called Tagging of Pacific Pelagics. Highly recommend it. We'll look at a couple of screenshots from it in a moment, but the TOPS program is really fascinating in the work that they've done. You can see here on the left what was the assumed distribution of elephant seals in 1991. And then after being able to apply these tags and get that really detailed information, now they know very specifically how far these animals migrate. Elephant seals are also another definite award winner in migrations. You can see the distance they migrate from our coasts here. Has anybody been up to like Año Nuevo to see elephant seals? All along the beaches, they're all along from Central California down into the Baja Peninsula are their breeding grounds, and they need to go offshore to feed, and they typically feed in deep waters up in the central North Pacific. And you can see how far, and they do this not just once, but twice a year. So they'll come back to breed, and then they'll go out and feed, they'll come back and molt, and then they'll go back out and feed again. So they will make these long migrations twice to do their foraging.
Wow.
So you can see the real fine scale information that we're getting, and this detailed distribution information. This is one of the screens also from Costa's work with the tagging of Pacific pelagics, and it overlays different species. So you can see the red is that same elephant seal map we were just looking at. But if you look closer, you can see, I love the orangish yellow of blue whales that have been tagged off of our coastline and where they are spending their time up here in the northern areas feeding. We won't get into all of these species. That could be 2 more hours worth of conversation, which I'm game if you are, but we probably don't have time. Some green tracks of fin whales moving along our coast. Then you can see that northern elephant seal, beaked whales, and even the blue lines of California sea lions, and where they move offshore to forage. So these tags have been really informational for us. And this cluster map here just gives you, I want it to be a little encouragement for you to head over to this project's website, Tagging of Pacific Pelagics. I believe it's TOPPS, TOPS, but .org. But you can see all of the species in this list that they've tagged and recorded to be able to study their movements all around the Pacific. Everything from birds, fishes, and sea turtles and marine mammals. It's pretty amazing when you see their distribution and their movements. Good. Any questions so far? I hope you guys are with me. I could just see a bunch of names, but thanks for those of you that have your camera on and are hanging tight. So let's get into the species that we want to know about, really, the ones that we're focusing on today, the gray whale, and then we'll talk about humpback whales. And you know, one of the questions that has always been is this statement that we make as naturalists. Oh, nice. Who do you got there? Martin? I don't know if that's truly Martin or the name is Martin, but who have you got on your shoulder there? Sorry, I have a little distraction. We've got our bird with us, the cockatiel, it looks like. So one of the questions and one of the statements that we often make is about gray whales migration and how long it is. And it definitely, I mean, I've long used the phrase one of the longest migrations of any marine mammal in the world. I also still always say that the blue whale is the largest animal that we've ever known. You know, I don't like to just make a flat statement because we don't know what's, you know, what fossils exist and what may have existed on our planet, you know, in outside of our time. I think it's just, and I think it's safe to say we don't know everything there is to know. We recently, for the Cabrillo Whale Watch Naturalist program, were able to host John Kalmakidis, who's one of the leading large whale researchers in the world, specializing in the North Pacific animals. And his talk was on gray whales. And his title was specifically like, the more we know, the more we realize we don't know, you know, and always, I think it said it was, his title was like always puzzling us or something along those lines. But, you know, there's just so much we don't know, and we're seeing a very small amount of their life. So, okay, that said, cutting here, this is a very familiar type of map. I'm sure many of you have seen it, and I'm sure this is probably us here about number 5 in different locations that you can see gray whales from shore, and or maybe we're number 6 actually. So anyway, the feeding grounds, recognizing again, we know the 2 reasons for this migratory trek is their feeding grounds and their breeding grounds. Can anybody tell me what our numbers are? What do we quote as the distance of a gray whale migration, that journey? You guys are all trained docents. Docents, you talk about gray whales.
5,000 miles.
That's right. Yeah, 5, right? 5 to 7,000 miles one way. Okay. That's the typical journey, the typical migration of the gray whale. Well, we need, there's the different locations that they forage and their distance of their migration, the 2 to 3 months of a journey. So talking about that distance, or that distance, let's keep in mind what we referred to when we were looking at the photo identification. Do you remember we were talking about not necessarily knowing individuals, and it's such a large number of animals that we don't have a catalog for all of these animals. We don't have individuals clocked at, you know, one extreme of the migration and the other extreme of the migration. When we say 5 to 7,000 miles, that's drawing the map and figuring out that if they were feeding up in the very northern end of the Chukchi Sea, making that migration, coming through the Unimak Pass, which is the primary area the whales funnel through, and heading down to the Baja Peninsula, if at the long end, if they were feeding up in the northern reaches of the feeding grounds and breeding down in the most southern reaches of their breeding grounds, that would be about 7,000 miles. So see what I'm saying? We don't know that one animal went from tippy top to lower bottom. We know that that's the range. And really, I think that's a very important distinction, is that's the range that they could migrate. The short end being if they were feeding maybe in the Bering Sea and came to the northern lagoons, or maybe didn't make that full migration. Okay, are we all with me? So that's the range of their ability to go, not an individual. Now let's take a look at this. We have some really fun information about the breeding cycle, and this was also shared by Dan Costa from UC Santa Cruz, and you can see that the circle. I like this along the bottom a little bit better, and I've got an animation from Oregon State to share with you that might help even illustrate this the best. So this is the breeding cycle of the gray whales. So they'll be up in their foraging grounds up in the Arctic, which includes the Chukchi and Bering Sea. They'll be up there for up to 6.5 months and make that southbound migration about 2 months, and then be down in the breeding lagoons for about 4 months. And then a little slower northbound migration up to about 3 months. You know, we always classified it as kind of 3 months. It's easy to say, and sometimes you have to judge your audience, right? If you're talking to kids, I think it's still easy to say they're feeding for about 3 months. I'm not saying super simplify it, because kids are brilliant. You know, kids will get it. But they're in the feeding grounds a little bit longer than our typical messaging that we say, and making that southbound migration quite quickly. And then here you can see the phase 2. Once that, now we have an individual animal solo, not a pregnant female. They're going to be up in those foraging grounds for about 5 months, making that southbound migration, shorter time in the lagoon, and then making that northbound migration again up there to get back to the foraging ground. Let's look at this in a video illustration. So this is from Oregon State University. And what they did here is they took all of their years of tagging data and made some, not estimates, what am I, what's the word I'm looking for? Anyway, oh my gosh, I completely went blank. I'm so sorry. Taking a step back, they took their tagging data and put it all together and came up with some generalizations in the amount of time they're together. So what you're going to see are these colors of migration. This is not one animal. The point being, this is not one animal. This is multiple tagging data all put together. So you'll see the female making her way in pink, a pregnant female, and then a male. Then you're also going to see a calf join the party here in just a moment. I'll loop through this. We'll talk it through once, and then we'll go through and let you watch it the second time, okay? But it's really interesting. Another thing to point out is that this is 2 years, because this is a breeding cycle for a female. So this isn't 1 year of migration. This is going to be the 2 full years. So check it out. I love this animation. So you can see them starting just south of their feeding grounds and making their way down to the lagoons, both a female and a male. And now we've had a calf join the party. And now they're hanging out in those lagoons, and you could see the male hightails it back up, and then the female and calf leave much later and make their journey a little bit slower up into those feeding grounds, where they will all stay foraging for, as we saw, at least 2 to up to 3 months. Up to 6 months, I'm sorry. And then they will make that migration. Once that ice starts forming, they'll make that migration again. Now you see there's no calf, because that calf is now an individual on its own. It may have been one of these males or females, but it's making its own migration as a juvenile, and they stay a shorter amount of time in the lagoons and head back up to the feeding grounds. I think it's a really neat illustration that really helps define this this migration, you guys want to see it one more quick time? So this is the Eastern North Pacific population, the primary population of gray whales, of which there are some 21,000. This is just generalizing us on what the breeding cycle is for males and females. Okay, we'll play it one more time. Oh, or not. Sorry. Now that calf's on its own, doing its own thing. Only stays with the mom for a short period of time once it reaches those feeding grounds.
Diane, in the example that you're showing here, was the calf born en route to the lagunas, or was it born in Mexico in a lagoon?
Well, again, it's assimilation of an assimilation of multiple calves, not a calf. But this seemed to assume most of the calves that were involved in this data set born around the peninsula, not in the lagoon.
Okay.
Why would a calf migrate the first year? I don't think they can have babies the first year, can they?
They can't, and we don't know if they do, except that we do know we see juveniles here along our Southern California, along the migratory path on a regular basis. So we do know we see them here. There's no reason for them to stay in their northern feeding grounds because that area covers up with ice.
Oh,
so we do know that they will stay around the like Vancouver Island, up in Oregon. There's many whales that will stay and feed there throughout the summer. I'm sorry, even through the winter, but there is an assumption that most whales come down to the peninsula, but not all of them. We know that not all of them do make that journey.
Diane, this is Sam Wilson.
Yes, hi.
How do they know where to go? I mean, if a whale is by itself, not part of a school, how would it know what its destination is?
Boy, if we could answer that. No. But to emphasize that, we don't know how they know, Sam. That's a very good question. And in this case, at the very least, we know that the calf is typically born down in the lagoons and makes that journey with its mom up north to the feeding grounds. So we know that at least once it's been shown where the breeding grounds are, you know, even if it's a newborn, and where it goes to forage. If you want to jump back to what I think is one of the most amazing cases, is that those elephant seals that we were looking at earlier, because anybody that's been to Baja with us knows, we'll talk about this often, is that those elephant seals, they're literally abandoned. They're fed on the beach with their mom. They're nursed for, 3 to 4 weeks. And then they, I'm sorry, for about 4 weeks. No, not 4 months, 4 weeks. Yeah, I was on right. Yeah. 4 weeks. Sorry. They're nursed from their mom, and then their mom splits and completely abandons them. And typically that's when we're visiting San Benito's Island on our Baja adventure. And we see a lot of fat, well-fed elephant seal pups on the beach crying because they're hungry and they don't know how to feed and they don't know where to go. And at this point, they start making that journey out into the water, dabbling around to see what to eat. They'll play with rocks, they'll play with kelp. They have to figure it out. And did you see how far offshore they go? I mean, that's crazy to think they figure that out on their own.
Diane?
Yes, Dan. Yes.
As I've been researching migration, and they talk about birds, they talk about genetics, and that the birds bring the evolution of their migratory paths over time. Can you speak to that with whales?
I can't, and I think that's a really still a very new thought or science. I think that they're looking at that in humans and what we carry with us, and whether it be physiological knowledge or insight and knowledge, what we carry through from our heritage as well through our genetics. So I think that's still a really new science that's not well understood. I can't speak to it, but I think there could be some of that. So gray whales, and we'll get to that in a second because we are going to talk about some tagging information, Sam. So on one hand, you might be just a step ahead of me, but it's a great question because we don't know. Yeah, so I'll save it at that, and we'll pick it up again in a moment.
Thank you.
Yeah, and that's the one thing I've always learned, and I think as docents, naturalists, all of us, and hopefully I think PVIC feels the same way, is just I have no problem saying I don't know. I think that we're, for many years we were kind of taught that if you're the expert, you're leading a tour, you're supposed to know everything. And I some of the foremost authorities don't know. How can I know? I have no problem saying I don't know. If I can find it, I'll look. But I think it's good for kids to know it's okay to say they don't know as well. All right, so moving on, and we'll see what else we can find out here. So I put this in here again just to revisit their feeding grounds. What do you know about the feeding grounds where gray whales forage? Anybody want to share, dust off some of your gray whale knowledge that you might be sharing again sometime soon? What do they eat?
It's shallow water.
It is, Adela. Thank you. That is one thing I was definitely looking for. It's shallow water. And what's the source? What's their prey? Their primary prey?
Grommelid amphipods.
Gammarid amphipods. Yep. Anything down in the mud, but primarily gammarid amphipods. It's one of their best sources of nutrition. And
Feeding grounds are moving up towards the Beaufort Sea.
And why is that?
Well, it's said to be because of our climate change. And
yep, go on.
there's less of an ice cap.
Less of an ice cap, exactly. So when the ice forms over this Arctic area, algae grows on the bottom of the ice during the winter season. And then when the ice recedes, that algae stays and falls into the ocean and becomes a source of food. It's a basis of a very rich food chain. And it's one of the reasons why some of that shallow water, it's shallow, so it's getting good sun, and then it's got all this great algae as a source of food. And it's what makes that area so abundant. So when that ice doesn't cover, then there's no algae, therefore it's a collapse in the food chain. So if we looked back at this video, looking just at the ice cap, I'll talk while it's moving, but if you're just looking at the ice cap, you can see that it comes down, into the northern Bering Sea and then recedes back north of the Chukchi into the Beaufort. And if our ice cap isn't forming all the way down into the Bering Sea, then you're not getting that food chain. So then the animals need to go further north where there was ice cap during the winter. So they, and so what we have seen is that we have a later migration sometimes because of that. And I think that has been documented that there's about a 2-week difference in the migratory peaks based on because of that, they're having to go further north. So they're leaving still around the same time when that ice starts to form, but it takes them longer to get to where we are because they've been feeding further up north. And as Sam mentioned, they were feeding in the Bering and then the Chukchi, and now they're even moving further north up into the Beaufort Sea. That was also one of the primary causes of this, or we suspect it's one of the primary causes of that big unusual mortality event that we've been experiencing now with the gray whales, because of the blob, or that warm water mass that formed off of our coast in 2014 and carried through 17 or so. There was very little polar ice cap. That big warm water mass affected even the Arctic, and we weren't getting much ice up there at all. And that really affected the food supply and the food chain. And so many of those animals weren't feeding and able to feed. So we saw some die off for animals that were starving. All right, so that was just a good refresher about where they're feeding and why and what this area is. And then down here to the breeding grounds. But again, just a reminder, we know that we don't have individual animals that have been necessarily photo identified in the Chukchi and then coming all the way down here and feeding in the southern reaches of the breeding grounds, maybe in the southernmost one in Magdalena Bay, which might say that they have this extreme range, this extreme migration. We just know they have an extreme range. Okay, so are we still all really good on that? Now let me add into it, just to add that next level. We're learning more and more about this Western population of gray whales, right? Historically, there have been 3 populations of gray whales. The Eastern North Pacific, which is our population. Eastern is confusing, but it's looking at the ocean, not our continent, right? So it's on the east of the Pacific. The Eastern population. The Western population here off of Russia and Japan. And then historically, there was a population in the Atlantic. Have you guys heard about the gray whales in 2010? And now again, this year, there's been a gray whale in the Atlantic. It's kind of crazy. That's likely because of the ice pack receding and opening that Northwest Passage and allowing them to make that journey through. I mean, that's what's suspected, and we don't know. There was also one seen off of was it Africa, Bernardo, I believe, someplace down in a southern continent. Yes, Anne, you're muted. I saw your hand go up.
Still
Okay.
here.
There you
Okay.
are.
So I read that there have been reports of an Atlantic gray whale sightings in Morocco in 2021, Namibia in 2013, and Israel in 2010. And I have all those articles of the sightings. Can you talk to those? So what do you think about that?
Yeah, well, that we think that that's because of the lack of ice cap and opening up that Northwest Passage and probably allowing them to, you know, slip around and slip through. You know, there was.
But isn't the Atlantic gray whale a different breed, a different species?
You know, they were hunted, exterminated, you know, so long ago, the 1700s, I believe. So I don't believe they were ever considered a different species. And when we do some, you know, genetics looking back, I wonder, there's been discussion and some early genetics work saying that the gray whale population used to be over 100,000, but that's not necessarily talking about the Eastern North Pacific population. Because remember, we always refer to this as a population, not a different species. So it's the Eastern North Pacific population, the Western population. They are genetically similar.
So you're saying that the Western population, the Western Pacific, the Eastern Pacific, and the Atlantic were probably all the same species.
That's
just your,
that's as close as we know, and I don't know what genetics they've been able to gather or do on the now extinct Western or Atlantic population. But interestingly enough, you know, I think if enough animals got over there, you know, at one point there was a food supply for them. You know, it doesn't seem to be the same 3 animals that have been reported there. I have photo identification. We've been able to look at them and check their markings, and it's not the same 3 animals. So, you know, did they get lost? Did they wander? Are these just curious animals? Did they just keep eating until they popped into new waters and now they don't know where to go? Sadly, the fate is not probably very good for these animals. We don't know whatever happened to the Namibia and the early Mediterranean, the first animal, and you know, they haven't been sighted again. So we don't know what's going on with them, and we'll keep an eye on the current one. But so it's always been long believed that the Western population, this Western North Pacific population, migrates south, just as the Eastern population does, right? Populations typically go breeding, feeding ground up in the rich higher latitudes, breeding grounds into southern warmer latitudes. And so now advanced science. Let's tag some whales. Hasn't always been super successful, but they did get one really good tag on a whale named Varvra. And Varvra's tag stayed. Varvra was tagged over here in Sakhalin Island, knowing it was a Western Pacific gray whale. It was tagged here in Sakhalin Island, and it made its way, interestingly enough, and nobody expected this, that it made its way not only across, but all the way down and into the lagoons, right down into the breeding lagoons.
Wow.
And then back up. So Sam, here we can look a little bit at your question, like how do they find their way? This was something that really kind of perplexed a lot of scientists. Is, you know, it just cut look at this straight line that it made across the northern area here, the North Pacific. And of course, following, we believe they follow the land, making that northbound migration and keeping, you know, we know that they travel very, very close to shore. We know that they will end up inside bays and harbors if they're, you know, and the thought is they're traveling so close to shore, they're just kind of going in and, you know, in and around. We believe they follow landmarks, bathymetric features. Here in Southern California, we see the largest migration path offshore, going from like Dana Point to the backside of Catalina, and, you know, cutting up behind the islands. So this was really interesting that it just seemed to make a beeline straight across and then all the way down into our breeding grounds. Now, it was traveling at a different time frame, so it came in a little bit later, and that's interesting because if you get the main pulse of your eastern North Pacific gray whales starting their migration from the foraging grounds here, let's just, for the purpose of conversation, put a month on it, right? So maybe the eastern North Pacific gray whales are starting this in September, making their way along the coast, and maybe this animal's also leaving in September. It's going to be quite a ways behind it. Do you see what I'm saying? So they're going to be substantially behind the main pulse of eastern North Pacific whales. If for by chance all those western gray whales are coming over to the eastern North Pacific, it would not be breeding with the eastern North Pacific whales. The eastern North Pacific whales, the females go into estrus the first time in November, typically around the northern US area, Oregon, Washington. Along that migration is when they're making, when they're first breeding. And that stays in line with our 13-month gestation period, right? So if they are being fertilized here and then making a full year's migration and coming back to those lagoons, it's usually about 13 months, right? That would be another month in the migration. You want them to be born down by the lagoons or in the lagoons. They do go into estrus a second time in February. So that might be picking up the late timers, or is it January? I'm sorry. But like when they're in the lagoons, they would be going into estrus a second time. So you might catch a Western Pacific gray whale being able to mate with a female, an Eastern North Pacific female, but there is genetic difference between the Western North Pacific and the Eastern North Pacific animals. So it's interesting to think, was this a one-off? Was this a random Eastern North Pacific gray whale that just kept inching further and further west and ended up way over in the Sakhalin Island area because it was looking for foraging grounds? Or is it a true Western Pacific gray whale that decided to go east or never went south? It's a very interesting question. So far, it's an N of one. We only know of this happening the one time. There was a second whale, Flex, that was tagged in the Sakhalin Island area and came across, and its tag stopped reporting in right around Oregon. So that might be cause for a second individual. So when we talk about long migrations, this is now considered the longest gray whale migration of an individual. But we don't believe that all our eastern North Pacific gray whales are going over into the western North Pacific. You got me? So we can still say that it's one of the longest migrations, but I wouldn't use this as the example when we're talking about all of them.
Mm.
And I know all it does is lead to more questions, right? But I wanted to jump into humpback whales for just a quick second. So how are we doing on gray whales? Any questions? I mean, there's probably 100 questions, but anything I might be able to answer briefly? Looks like Anne, are you popping in with another question? You always got good ones.
Yeah. So I've been reading about blue whale, fin whale hybrids.
Anne, gray whales.
No, I know. So what I'm
I
talking about is the western gray whale and the eastern gray whale interbreeding.
Oh, yeah. So that would be blue and fin are different species. So
Right.
that is becomes a hybrid. These are different populations of the same species. So it wouldn't be a hybrid. It would,
Okay.
it's possible that they could genetically reproduce. It just doesn't seem that their timing is right. If they're truly all Western Pacific gray whales are going to the lagoons, it's likely that their timing is off. And so, yes, maybe it's just a spillover of our Eastern North Pacific and we've expanded the range. There's only about 150 to 250 animals in that population. It's not an abundant population. So again, I think that would be case to say it's the outlier, not the general, if we're going to, again, use that, term about the longest migration or not.
So the only way to, if you really wanted to get into that and really prove it, would to have the genetic analysis of each species or each different population, and then take that, if you could, we don't have the money or whatever, to take a biopsy of that one whale that went all the way down from the west and see if genetically, but we don't know.
I would imagine the genetics were done on that. If they were able to get in there and dart it, usually, put the satellite tag, typically in an effort to get as much information as possible and be as least invasive as possible to a large number of animals. If they are going to tag an animal, there's a chance that somebody was probably getting a skin sample at that same moment. They'll get a photo ID, skin sample, everything they can at that moment. Now, this is not a tag that's going to fall out, so they can't get genetics off of the tag. But all very good questions. All very good questions. Yeah, absolutely. I would say, even Bernardo, do you have anything to add before we move on?
Well, I'd like to just point out very quickly that genetics is not as clear cut as we as laypersons tend to think. Basically, in a nutshell, what happened was that for years, the geneticists were saying, yes, we look at the genetic data and we see that the Western gray whales are separate from the Eastern gray whales. And then once we saw that they came across, we said, oh, they might be interbreeding. And the geneticist says, yeah, looking at the data, it's possible that they're interbreeding. So there are no clear-cut answers. It's kind of all part of a much bigger picture that's much more complicated. And basically the answer is we don't know at this point whether we cannot prove if they interbreed or not.
Yeah, thank you, Bernardo. Yeah, genetics is still, as much as we know, and as much as we're learning, it's still, I think relatively new, a new science. So I'm really, well, that's probably too early to say. Stay tuned. I'll just leave it at that. All right, well, so let's jump into, I think I have 3 minutes to talk about humpbacks. So we'll zoom through this really fast.
Diane, I think if everybody's interested, they'll let you go past an hour.
I will, feel free to jump off or ask questions, but then we'll until Denise, Norman, Ann give me the big hook, I'll just keep answering questions and rambling on. So, humpbacks, and I think it's really important, as at Cabrillo Aquarium, as well as the Cabrillo Whale Watch program. We're starting to really diversify. We kind of held on to gray whales being the primary species that we see here in Southern California. But guess what, everybody? They might be the first and primary, but they're not the only species we're seeing here in Southern California on a regular basis anymore. Humpback whales, fin whales are being seen throughout the year. Humpback whales are here almost year round. Fin whales here quite a bit for several months, a couple different times of year, including right now. Blue whales we see here through on or off through the summer, depending on the season. I'm really hoping with this La Nina and all the winds we've been having, maybe we'll have another one of those good blue whale years. Does anybody remember that 2010 and 11, those crazy blue whale years? But the point being, humpbacks are worth learning a little bit about, because they can be seen off the peninsula. They can be seen right from your patio. Probably this week, you could probably take a look out and see a good number of humpbacks, because they have been around. There's some amazing ways. We talked about the ways to study them. All of the stuff still holds true. In many ways, they're easier to study than gray whales because of the underside of their flukes. They show those flukes all the time, but there's also fewer of them here in the Eastern North Pacific. So there's probably 2,500 to 3,000 that are in the catalog in the Eastern North Pacific. Much easier to keep track of than 20,000, as you can imagine. Cascadia Research holds the primary catalog. A great way to participate in citizen science and contribute to the understanding of humpback whales, and just to poke around and play, is to take a look at Happy Whale. Happy Whale is a citizen science catalog. It's gathering up all the research catalogs as primary sources, and then if you upload your photo, oftentimes within just a few minutes, the algorithms will get to work and shoot you back a response and let you know what individual you're seeing and when it's been seen before, and then you'll get regular updates. So Happy Whale is really cool. I highly recommend you check that out. So let's take a look at what we do know about humpback whales. Yes.
Are the two populations of humpback whales north and south? Are there some from the Antarctic as well?
There are 13 distinct populations of humpback whales in the world. So we're going to talk about those at this very moment. That was a good introduction. Thank you so much. That was a perfect segue for me. And so there was an amazing big international multi-continent, multi-agency, everything but one ocean. The North Pacific study of humpback whales was done in 2004 and 5, I believe, or and 6. It was called SPLASH. It was a study of population levels, level and structure of humpbacks. SPLASH, greatest acronym ever, if you ask me. I think they did a really great job on that. They had people in all the different breeding and feeding habitats known in the Eastern North Pacific, taking photo identification, taking genetics, taking anything that they could in a non-invasive or under, particular laws, ways, very careful, but then they put all of that together. And this is what we learned about humpbacks just in the Eastern North Pacific. And here you want to look at the different colors, and then also the different dots showing and considering that this would all be considered the feeding area. And then these are all the breeding area. The lower ends of all those dots are the breeding areas. And so you can see that here, if you just look along our central US coast, we are getting animals from Costa Rica and central Mexico, as well as Baja. So there's kind of 3 different areas, 2 populations that our animals are coming from. We don't have the Hawaii, Alaska population is different than the animals that may be feeding off of California typically. There's something like a 1% rando that comes over, probably like Barbara, that maybe made some offshoot. But our animals typically are breeding off of anywhere between central, like Costa Rica, central Mexico, up into Mexico, and feeding here in California. So that's just a look at the Eastern North Pacific. Here is, and this was very new science, because what they did was they looked at all of the breeding areas of humpback whales around the world, and then did an assessment of the health of each population independently, instead of looking at them all and categorizing them all as endangered or threatened or none of the above and just healthy. They looked at individual populations from the breeding ground perspective, and then they were able to break them up into these distinct population segments and designate them appropriately as endangered, threatened, or not at risk. And you can see that many of them were found to be healthy and doing very well and removed from the endangered species protection levels, which many people kind of, you know, scoffed at in many ways. Like, why would we remove their protection if any of them still need protection? But conservation educators, conservation researchers, we need some success stories, and to be able to break these out and look at their distinct populations and be able to say these are thriving and doing really well. Number one, lets us say the work we're doing is successful. We're on the right track. But also now we can look at those populations and see what is going on with them and maybe apply that to some that aren't doing as well. And you can see that here our populations are still threatened and endangered. These numbers 5 and 6 are the ones that would be coming and feeding off of California. So the populations of humpbacks that we could be seeing are still considered endangered or threatened. But I think it was Brian Tilley, does that give you a better idea here? There's, I'm sorry, 14, not 13, 14 different populations around the world. And so each of those then will go, the North Pacific or the Northern Hemisphere, you can see the lines denoting what their feeding grounds are. And for the Southern Hemisphere, they're all converging down into some part of the Antarctic for foraging grounds. But you can see the many different populations here. Just giving you, an idea here between Costa Rica and Antarctica. This gives you a little bit of the distance as well. So now we're looking at 5,000 miles. Again, if we're talking about those distances, it's very similar to the distance of a gray whale migration. And in this case, there are populations on both sides of all the southern continents. But this was just nice, a quick illustration to show the one between Costa Rica and Antarctica. And mind you too, do you remember our animals here in number 6, our distinct population in number 6 that may be foraging off of the California coast? Notice where their breeding ground is also in Costa Rica. So Costa Rica is an interesting area where there could be some overlap of animals that go to the Antarctic and animals that are foraging in California, but they're believed to be there, in different times of year, and that using that as a breeding ground. So they may or may not be overlap, and that's an interesting area of study. And here's a kind of a crazy swirly map. It's not showing. Anyway, I was trying to make a joke, but I won't because I'm losing my words. You can see all the migratory paths of humpbacks throughout the world and the many different populations. And so they are all the same species, but they're all different, distinct populations, typically don't interbreed. These do give us some indication. That's kind of stage 1 of if you were starting to look at different breeding ground or different species and species, separating these into species. But at this point, they are still all one species of humpback across the entire world. So here's our story. This picture is a picture of an animal who was photographed in Brazil by researchers. And then several years later, somebody was, fortunately, well, let me back up. Let's see. So then it was several years later, somebody was on tour on holiday in Madagascar and took some vacation photos and posted their picture to, it was like Google Photos now, whatever. I can't remember what it used to be called. Trying to look for the word of that, but anyway, to like Flickr. And there was a College of Atlantic researcher that was just trolling through Flickr looking for photographs to put together catalog, looking for photo identification, humpback, Google searching in Flickr, humpback whale or flukes, and found this photo and found a match from Brazil to Madagascar. Brazil to Madagascar. Now, if you take a look back at our map, Brazil, Madagascar, not a typical back and forth migration, right? It's not where you don't usually see them changing breeding grounds this way. There's not much usually typical lateral movement. It's and so from Brazil to Madagascar is they do this in kilometers. 9,800, I believe, is the distance from where photo A and photo B was taken. And mind you, though, that doesn't include the fact that that whale more than likely went down to the feeding grounds in the Antarctic. It has to feed, right? It would have to have fed. So, and this is an individual, right? Now, again, so if we talk about our gray whales and their range, and we only know one individual, Varvara, who's very specific movements. And here we also know the range of most humpback whales. And but the most of these we know because of individuals and photo identification. But this is another single individual, another interesting one-off story of an individual who was documented here off of Madagascar and then again off of Brazil. And so its journey being, again, I here, where's my notes? I believe it was 9,800 kilometers. Bernardo, can you calculate that for me? What's that in miles? Anybody a good math quickly? But I think that's a little bit more than 5,000. I think it's 6,000. Anyway, he'll get that really quickly. But that doesn't count it going to Antarctica because we can't prove it, right? Well, we can prove is Madagascar to Brazil. We can't prove Antarctica, likely Antarctica, but we can't prove it. So again, when we talk about, the longest migration of any animal, we have to consider all those things that we don't know. So I am going to end by saying, I still think it's safest to say one of the longest migrations of any mammal. And that's my bottom line. And there's a lot more about humpbacks we could talk about too, but since it was specifically about migrations and populations, I wanted to hit on that. And that is 7 minutes over my time. And you guys stuck with me, so thank you. Bernardo, what's the mileage on that?
6,000.
6,000, yeah. So that would be a little bit longer than.
Thank you, Diane and Bernardo.
Yeah, thank you.
Everybody, you're going to be seeing a lot more of them, I'm hoping, in the coming years.